All right there. Hi, cuties. I am so excited to talk to you today about the ambiguous case part 2, which is the algebra. Not just the pictures, but the algebra. But to start our conversation and to get to the algebra, let's talk about the pictures one more time. So what is possible when you have the angle, side, side, or ambiguous case? What are the possibilities? Well, you can have a triangle that looks like this, where you're given angle A, side B, and the opposite side A, opposite the angle that you're given, and it's just not long enough. And in this situation, no triangle exists. You can also have the situation where you have exactly one triangle. Oh, by the way, this one over here, the no triangle exists case, that's because A is significantly smaller than B. Okay. It's because A is significantly smaller than B. So now we've got possibilities for one triangle, and there's a couple of different ones that I can draw for you that are examples that all work. And this situation right here, you've got your angle A, you've got that same B and an A over here. And the difference in this one is that A is greater than B. So that makes a difference because A is greater than B. And you could also have this situation where you've got maybe an obtuse triangle. You're given angle A, side B, and side A. Side A is significantly bigger than side B. A is bigger than B. You've got that same situation. Okay, and then there's another situation where you can get one triangle exactly. And you can get one triangle exactly if you've got a right triangle situation. So you've got your angle here, and it just so happens that, oops, B and A here. In this situation, A is equal to H, where H is the height. Okay, so those are the different scenarios. Some of the scenarios you can have to get exactly one triangle. Let's box those up so they kind of stand out. And then we get to the fun situation, the fun cases where you can get two triangles, but it sure is tricky. So let's see here. We've got, what do I want to do? Let's go like this. And we're given angle A, we're given this, and we're given this A value. And I don't know if you can tell, but this A is going to be longer than the perpendicular, the height right here. So do you see that A is bigger than what would be right there? Kind of think of this as a pendulum. If you could swing it back to this way, it would hit right there as well. So this is also A. And now you've got a situation where you've got two triangles. You've got this one right here. And then you've got, I'm going to do it with squiggly lines. You've got this one right here as well. There's actually three triangles if you look at it. There's this obtuse one, there's this big one, and then there's this cute little isosceles triangle right here. We are not interested in the isosceles triangle. We are interested in the two triangles that both have angle A and side B. We are interested in the two triangles that come from angle A and side B, not this cute little isosceles one right here. So we've got this, the obtuse triangle, and we've got squiggly line triangle here. Those are two different possibilities. Two different triangles. Two different totally unique triangles. Okay, so that's just to remind you what's happening. So we are now going to go do the math that we're going to go show you the math for each of these cases. What does the math look like when no triangle exists, the algebra or the numbers? What does it look like when you've got one triangle, and what does it look like when you have two triangles? So you need to go ahead and take out your notes if you don't already have them out. And we're going to start here. You should have this slide. If given two sides and one opposite angle, either no such triangle exists, exactly one triangle exists, or two distinct triangles exist. That's exactly what I just showed you with pictures. I'd also like you to point out that I gave you a page to turn to. When you start your homework, if you'll take an extra 2 minutes to look at page 430, It's got really good pictures. I've never written this on your slides before to go turn to a page in the book, but I did here because these are good pictures. The more times you look at it, the better. And it's gonna look something similar to this, which I just realized I forgot to put something really important right here. What I wanted to point out here is, in this situation, A is bigger than H. It's bigger than what the height would be right here, but it's less than B. I forgot to say that, and that's important. You can tell this one's gonna have two triangles because A is bigger than H, but it's less than B. If you look over here, A is less than B here, and A is less than B here, but it's totally different situations. This is kind of a small A, and this one's a bigger one. So we're gonna show you what that looks like with the math here. Okay, so hopefully you can see. I wish this was bigger, but it's not. So we're just gonna deal with it. You've got it on your slides in front of you, and hopefully you'll be able to see my handwriting. Okay, so we're gonna start by drawing our triangle. Okay, and so I've got angle A is 32 degrees. Side B is 10. And now A is supposed to be 12. So it's longer. So if you had to guess, which situation do you think we have? Do we have no triangle, one triangle, or two triangles? If you had to make your best guess, what do you think we have here? Oh my God, great job. No, I'm just kidding. I have no idea what you said or what you think, but the answer is I think that there's one triangle. I think that this is the situation where A is greater than B, and so we're gonna have one triangle. This is angle side side. I wanna recognize that early on, and now my job is to go find B, C, and little c. Now, this first example is gonna take a long time for us to get through. I'm gonna explain a whole bunch of hard stuff. This is super hard logic. I think this is the hardest logic that we go through all year. It's gonna take me a while to do it here, but then the next two slides will go much faster because of the work that we do here and the time that we put into it. So just know this is gonna go slowly. So first thing we're gonna do is we are going to go look back one page on your slides, and you're gonna go see the two different formulas for the law of sines. So if you do that, do you remember that one of them had the angles on top and the sides on the bottom? We want that one because we are trying to find an angle here. And when you're trying to find an angle, you want to have the angles on top. It just makes it easier. So I am going to do my algebra before I substitute. And now you do need a calculator out if you don't have one. Also, right here, when you're trying to find an angle, you're given the sine of B, but you want that angle B. That's when you have to use the inverse. Because remember, that inverse button gives us angles. Okay, and so now I'm going to substitute in. B is 10. Sine is 32 there, divided by 12. Now bust out your calculator and see if you can get what I get. I'm going to give you a second to do it while I calculate it myself. So go ahead and make sure your calculator's in degrees, please. Okay, let's see, there's that. Half the battle here is knowing how to use your calculator. And I got 26.2, rounding to the tenths. Make sure you get a degree symbol and an approximation symbol. And then I want you to stop. Please don't work ahead. Because I'm sure you're dying to work ahead, because who wouldn't want to, because this is amazing. Okay, so here's where it gets hard. I'm going to bring back my other piece of paper just for a moment so I have a little bit of a place to write. So I have two things that I want to share with you. Your calculator has limitations when it comes to the inverse trig functions. And I don't know if you remember back in 4.7 me saying that I really wanted to teach you 4.7 about the inverses because it's what dictates kind of how your calculator works, and your calculator is only as smart as you are, and you have to understand what you're getting from it. Well, this is the example that goes with what I said there. So your calculator just spit out, well, hold on, let's not worry about what it just spit out. Let's pretend for a second that I gave you this problem. The sine of theta is equal to 1/2. And I said, okay, let's solve that for theta. So if we want an angle, we use sine inverse. Now, if you go use your calculator and you do the sine inverse of 1/2, see what you get. Hoping that you get 30 degrees. See if that's what you get. That's great that you got 30 degrees. Is that the only answer to this? Is that the only time that sine is equal to 1/2? Well, the answer to that's no. Your calculator, however, thinks that is the only answer. Your calculator is going to give sine inverse answers in the fourth or the first quadrant. And positive ones are going to be in the first quadrant, negative ones are going to be in the fourth quadrant. So we're not even going to be dealing with this. We're only going to be dealing with, sorry, hold on. Okay, sorry. We're only going to be dealing with first quadrant answers. So your calculator is going to spit out an answer like this 30 degrees in the first quadrant. Well, that's great, except for we know that there's a second quadrant possibility right here. And it's the same family of angles. Instead of 30 degrees, it's 150 degrees. It's the obtuse angle that goes with 30. So both of these are legit, but your calculator only gave you one. Both of these will give you that answer, but your calculator was only able to give you one because it's going to give you a first quadrant angle. You have to be smart enough. You have to know that there's a second quadrant angle that's possible. So that's pretty crazy, tricky logic. Okay? So I'm going to come back to that in a few minutes. I'm going to go back over here. As soon as you use the sine inverse button on your calculator, it's giving you this answer, but there's the possibility of a second answer. There's a possibility of a second triangle that has an obtuse angle, not this one. So here's where things get cray-cray. We're going to look and see, is there a possible second angle B that might work? And the way we're going to do that goes right back to this. Math-wise, if you're given the 30 degrees and you want to find this one, how do you do it mathematically? You take 180 and you subtract 30 to get the 150. So if we're given 26.2 and we want to find our other second quadrant possible answer, we're going to go 180 minus 26.2. So go ahead and do that on your calculator. And you should be getting 153.8. Now, this would be, if you were looking back over here, sorry to be flipping around, I'm not sure how else to do this. I'm not very sophisticated when it comes to this recording nonsense. So this is the 26 degrees. We're possibly finding this one. See how it's obtuse? We're trying to find this angle right here, and we're trying to check to see if it works. Well, what do we need to check to see if it works with? We need to check with the original angle and see if these add up to be a number that's bigger than 180 or smaller than 180. If these two numbers add up to be bigger than 180, then there's nothing left for this angle to be, and there's no triangle. If these two numbers, the B you just found and your original A, add up to be less than 180, then there's a second triangle that exists. So, question, does this allow for a second triangle right here? Okay, and the answer is no, because if you take this and add 32 to it, you are already above 180 degrees. No second triangle exists here. We just checked, but one didn't exist. I already knew that, because if you look over here, this side is way bigger than this side. Do you see how A is way bigger than B? I already knew that, but I wanted to show you that the math shows it as well. In case your brain doesn't look at this and totally understand the triangle thing, you can always figure it out from the math, which I find to be reassuring. So now that we know that there's no second triangle, because 153.8 plus 32 degrees is way over 180, doesn't work. So now we know there's not two, we're just gonna finish this one. So now I'm gonna find C, and C is gonna equal 180 degrees minus 32 that we started with minus the 26 right here. So C is equal, or approximately I should say, because it's using approximated numbers. Okay, so that's 121.8. And And that's also an angle, so please get a degree symbol on it. Now, last thing that I need to do is I need to find little c, which is side C, right there. Oh, look how cute I am. I called it C1. Oopsies. That's just C. My bad. Should I start the whole thing over? God, no. Okay, I just like making jokes to myself, too. I think that's a lot of fun. Okay, so now, am I going to use this version of the law of sines to find a side? No, no, no. I'm going to go back to this dude because it's going to make my math a little bit easier. Not a ton easier, but easier. And I'll take easier. So C is equal to the sine of 121.8 degrees times 12 divided by the sine of 32. If you're having calculator issues, which some of you are going to, just let me know. We can work on it. So take a minute and calculate. And I got 19.2. Remember, you can pause at any point here and stop. If I'm going too fast for you, you can rewind and listen to it all again. Yay. But you're going to hear it a couple more times throughout this lesson as well. So your job right now is just to try to understand what I'm talking about to the best of your ability, but you're going to keep hearing it a few more times. Okay, so things I want to point out on this problem, if I can remember all of it. I had a really good question in first period. Somebody asked me, well, where does sine come from if this is not a right triangle? Which I thought was an excellent question. Thank you, Ubaid. Okay, so here's the deal. When we were given, like the people way back in the day who come up with this nonsense, they had a not right triangle and they went, well, dang, what are we going to do with this not right triangle? And they dropped a perpendicular and now they had a right triangle. And so they said, well, I took a regular triangle that's not a right triangle and I turned it into two right triangles. So now we can still use what we know about opposite, adjacent, and hypotenuse and write some ratios. And that's where this came from. They took this and started comparing ratios of the A's to the B's to the C's and all that kind of stuff. And so they came up with, that's where this is coming from. So I thought that was an excellent question. Another question. Aren't these two formulas right here basically the same thing? And the answer is yes, they are the same thing. How come we use different ones? It has to do with what you're solving for. So right here, if I used this formula to solve for little b, I'd have to do more algebra. I'd have to move that little b up. I'd have to multiply by the reciprocal to get this thing flipped to the other side, and then I'd have to take the sine inverse. That's a lot to think about with the reciprocal and everything. It's much easier just to multiply the b up and do the inverse. Likewise, over here, I could find angle C if I wanted to. I'd multiply sine C up. I would divide this over to the other side, which is multiplying by the reciprocal, and then I would take the inverse. The problem is that it's just it's a few more steps, not a lot more steps. It's a few more steps, and it's more places to make mistakes. This is much cleaner and easier. Let's see. Those are two things I wanted to say. I guess that's about it. I feel like there was something else, but I can't remember. Okay, so we're going to move on to example number 2. That's the hard part. We got it out there, and now we're just going to practice it a couple of times. Okay, so here we go. Example number 2. Hopefully you can see it there. Let's start by drawing the triangle. This is a 10. Ask yourself, what do you think's happening here? Do you think this is going to be 0 triangles, 1 triangle, or 2 triangles? And I'm hoping that as you're drawing this, you're not just copying me. If you are drawing it, I'm hoping this is what your brain is thinking. That this 2 is not long enough to get it all the way across there, but I don't know, so I'm just going to connect it like that, and I'm going to let the algebra or the numbers speak to me. All right, so I'm going to go for B right here. So the sine of B is equal to, the sine of B over B is equal to the sine of A over A. So B is equal to sine inverse. I'm skipping a step or two there. I hope I don't freak people out. Sine A over A. So B is going to equal the sine inverse of B, which is 10, times the sine of 32 degrees, divided by 2. Now go ahead and go do that on your calculator. I want you to see what happens. If you go ahead and do this on your calculator, maybe hit pause right now until you've got it done, and then come back and check. When you do this on your calculator, you should be getting a crazy math sign like a domain error or math error, it might say, that kind of thing. And the reason why you're getting that is because if you were to take this and just calculate that part, it looks like this. And the question is, how come this does not exist? I hope you're thinking about that, not just waiting for the answer. No triangle exists because of this right here. I don't know if you can see all this. Let's see. Okay, so take a look. Sine inverse. Sine inverse, the domain is -1 to 1. Sine inverse of 2.6 does not exist or is a domain error because this is bigger than 1. So I would need this to be between -1 and 1 to be able to get an answer, and it's not. That's why the triangle does not exist. And you can see it right there in the math. I am not expecting you to write this step. I just did that so that you guys could see that was a number that was bigger than 1. I literally almost just said any questions, but I guess that's kind of stupid because I'm talking to myself. Okay, good talk. All right, so last one. Here's where the fun begins. You're doing great. Isn't this fun? Love math. All right, what do you think is going to happen here? Sorry about the shaky table. I'm trying, but it keeps shaking. I hope it's not making anybody seasick. This is the case where you get two triangles. So let's see what that looks like. And it's going to take some space. You might end up having to work up there. Actually, maybe I'll draw my triangle up there to give myself a little extra space. Okay, so watch. I'm going to draw. Okay, so this is a 9. Now, could go either way, right? So I could have this triangle, or I could have squiggly triangle. Okay, so I have two possibilities. I either have this little triangle, big obtuse angle, 32 degrees 10, or I have this one, which has 32 degrees and 10, and this angle over here. Okay, so let's see. I think this is what's going to happen, but I'm not sure. I'm going to do the math. So I'm going to go sine of B. I'm sleepy. I want to go night-night. Okay, and then B is going to equal sine inverse of 10 times the sine of 32 degrees. And that's going to be over 9. B is going to be approximately, let me calculate it. Now I'm hungry. I'm tired and hungry. 32 equals that times 10 divided by 9. Okay, I got 36.1 degrees now. Remember, anytime I use the sine inverse button, I have to be worried. When I come back to here, anytime I use the sine inverse button, I have to be worried about the fact that my calculator is only going to give me one answer in the first quadrant. I need to consider my second quadrant answer. To get that second quadrant answer, I subtract from 180. So over here, I'm going to do 180. This would be B sub 2 if it exists. 180 minus 36.1. So B sub 2 would be approximately whatever it is. I don't know. I should know. I should totally be on it. 143.9. Now, is this second triangle possible? I'm not sure why I'm waiting for somebody to answer me. Is the second triangle possible? And the answer is yes, because if I take 143, really, let me go back to a picture here, maybe right beneath it. Let me see if you can see both of those. Okay. This right here is the 36.1. Now I just found 143.9, which is this obtuse angle. This is B sub 2. Now I want to know, does this triangle exist? And the answer is yes, because 143.9 plus the original 32 degrees, if you add those two things together, those are less than 180. If they're less than 180, then the triangle exists. So I've just found B sub 1. This is B sub 1. I subtracted it from 180 to get my second quadrant angle that's of the same family, and that's going to be 143.9. That's B sub 2 right here. Now I know that this second triangle right here in the blue, I know that that exists because 143.9 plus 32 is less than 180. So as soon as I know I've got two triangles, I'm going to draw a separating line right here because I want to keep my two problems separate. So I'm going to treat these literally like two totally different triangles. On this triangle, I have to solve for B sub 1, C sub 1, and little c sub 1. On this triangle, I need to solve, I've already got B, I got to solve for C sub 2 and little c sub 2. So I'm now going to treat them totally differently. I'm going to treat them totally differently, whatever. Okay, so now to find C sub 1, that is up here. This is B sub 1, this is B sub 2. Can you see all that? Yes, hopefully. Okay, and then this is going to be C sub 1 is going to be that big sucker. C sub 2 is going to be that cute little guy. C sub 1 little is out here. C sub 2 is right there, second triangle. Okay, so how do I find this big angle? I'm going to do C sub 1 is equal to 180 degrees minus 32 degrees minus 36.1 degrees. So C sub 1 is approximately whatever it is. 111.9. Okay, now I'm going to find side C, and I'm running out of space. Boy, your teacher should give you more space, huh? Where do I want to put it? I'll put triangle 1 right here. Triangle 1. So here we go. We're going to do little c over sine C equals sine of A. Ooh, Miss Hass, nope. Oh, and pen. We're going to do A divided by the sine of A. So I'm going to have C sub 1 is equal to the sine of 111.9 times 9 over the sine of 32. C sub 1 is approximately what? Let's see. It's a lot more fun when you guys are in class. Just saying. Much rather teach human beings. Who could do this for a living? Record stuff and I don't know, whatever. Do we get 15.8? I think. Okay, so 15.8. Uh-oh. Yes, we're in school.
Please release all cadets in uniform today at 2:30.
Okay.
Yearly picture at the flagpole. Again, release all cadets at this time.
Okay. Mm-hmm.
Yearly picture at the flagpole.
Right. Okay, so we're almost done. You guys are doing a great job. I know this is hardcore. So we found B sub 1 from the first triangle. We used that to find C sub 1. And then we used that C sub 1 and A, sine of A and regular A to figure out that the side was 15.8. That is all triangle 1. Normally I like that work to be all nice and organized where you'd see all of angle 1 here and all of angle 2 here, or all of triangle 1 here and all of triangle 2 here. But I'm out of space, as I'm sure you are as well. Okay, boy, your teacher needs to do better. Okay, so now crazy part. Here it is. This is the hard part. So we went through and we found this second possibility for an angle, this obtuse angle right here. We went through and we found that, and it's 143.9. How do I find this angle C right here, C sub 2? Well, it's going to be 180 degrees minus 143.9 minus the original A angle, which is 32. So C sub 2 is approximately what? I don't know. It's going to be teeny tiny. .1. 4.1. Cool. Okay, and then finally, we are going to find C sub 2 over sine of C sub 2. Notice how we really want to use this, not something from over here. We're in a different triangle. Okay, so C sub 2 is going to equal the sine of 4.1 degrees times 9 over the sine of 32 degrees. C sub 2 is approximately what? I didn't know. Let's figure it out. Boy, I'm about to go to sleep. This is hardcore. I mean, I've got a winning personality and you should all be really excited. Are you still listening to me? Who's listening to me? Nobody? Oh, look, it's like every day. Okay. When I talk and nobody responds to me. All right, so there it is. There's your ambiguous case. Those are your 3 different possibilities of what can happen. Hold on, let me see if I can get it all out here. Ooh, I wonder if you can see all that. Cool. I think you can. Okay, so we've got exactly one triangle exists, we've got no triangle exists, and we've got 2 distinct triangles. You've got angle or triangle 1 and triangle 2. That's 6 answers total. You want to be really careful and make sure that you don't make a mistake right here because it makes all your other answers wrong, which would still get you a lot of credit because you had the right process, but still would be kind of sucky. Mistakes and confusions that I'm used to people asking about. Right here, this is going to sound weird, but just bear with me. Is this 180 degrees the same as this 180 degrees? The answer is no. This 180 degrees, let me see if I can get all this in. This 180 degrees right here is coming from us trying to find the angle in the second quadrant. This 180 degrees is coming from the sum of the angles of a triangle is 180. So I know they're both 180s, but their context is very, very different. This one is finding the quadrant 2 obtuse angle. This one is finding the missing angle from a triangle. 2 totally different things, so be careful. This tends to be the errors here, okay? So now if you look at the next slide, there's not enough space to do these 3 problems, so you need to take out a piece of binder paper and you need to work on these 3 problems. Now, you have to be really careful. If you look at B and C here, they switch up the order or the given information. It's no longer A's and B's, it's A's and B's but in a different order, and it's B's and C's. This jacks everybody up. What you need to remember when you go to draw these triangles is always draw the triangle like this, and whether they give you A, B, or C, you label this angle in this orientation that we're used to with whatever information that they give. In this case, it would be angle A, in this case, it would be angle B, and in this case, it would